So with number 9, a block of mass 20 kilograms rests on the floor of a lift. Find the reaction between the block and the floor of the lift if the lift is accelerating upwards at 5 meters per second squared. So we're told it's going upwards, so A is equal to 5, yeah? What we want to do now is focus on this block. Okay, don't worry about the lift in terms of the weight of the lift and the tension in the cable that's pulling it up. We're not going to focus on the lift itself. Okay, so we're not worried about the forces acting on the lift. I'm just going to focus on the forces that are acting on the block. Okay, if you think about forces that are acting on the block, well, the block has a weight, doesn't it? And the weight of that block, well, you take the mass, which is 20, and times it by g. So you've got the weight of that block, and the other force affecting, of course, then is the fact that that floor of the lift is supporting it. So there's a reaction there from the floor. If that floor wasn't supporting it, the block would just fall straight through, wouldn't it? Okay, but it isn't. It's sitting at the bottom of that lift, so it's supporting this block, okay, with that reaction force there. Okay, they're not going to be equal if the lift is accelerating. Okay, and it's important for you to get your head around this, that if the lift is accelerating at 5 meters per second squared upwards, well, so is the block as well, yeah? Because whatever the lift is doing, the block is doing also. So it's actually accelerating upwards, this block is. So that means then we have a resultant force. The resultant force is not equal to 0. Okay, so if I apply Newton's second law, I can say, look, the resultant force is equal to mass times acceleration. Well, because it's going upwards, this r has got to be greater. It's got to be, right? Because the block, if you think of the block, it's accelerating upwards, isn't it? It is increasing speed on its way up. So r has got to be greater than 20g. And of course then, applying Newton's second law will be the mass, which is 20, times the acceleration, which is 5. So notice, I'm just concerned about the block, as I mentioned earlier, and don't care about the lift, right? The lift helps us because we know it's accelerating at 5 meters per second squared, which is going to be applied then to the block. The block's going to have the same acceleration. But I'm just focusing on the forces affecting that block. Okay, and I'm applying Newton's second law to the block. And you can say that if you want, okay? So you can say apply Newton's second law to the block. Okay? So it's the case then, I'm working on r from here. So 20g, 20 times 9.8. 20 times 5 is 100. Okay, so 20 times 9.8 will be 196. So then a little bit of a rearrangement, then take that over, you get 100 plus 196. So R will equal to 296 newtons.